So now let's talk about the storage of time series data, right? So we talked about like if you already have the data on file, how you could do this. But usually there's a lot more going on, collecting the data, making the data available, and so on. So I want to briefly discuss like some of the use cases and the different options you have to collect the data to make it ready for time series analysis. All right. So actually there are like two main use cases for time series analysis. So either you're actually using the data in some kind of automated analysis, right, to make predictions, to do outlier detection or something like that. Or you are using the data for monitoring, right? So you would have it somewhere and then you would maybe see it on a dashboard or have alerts, or you use it for more interactive analysis, right? But usually you only want to have one infrastructure there where you can put your data. And this means you want some way of collecting the data, storing it, and then accessing parts of it, either very often in certain time ranges, but sometimes also when you have like lots sensor data, let's say, you want to go in and actually just figure out this one kind of metric for this one machine. So you must have a way of not only reducing the time range, but also filtering the data on some way. Right? And then depending on the different different approaches you can make to store the data, they all have different advantages and different disadvantages when it comes to these two requirements. So the classic is to just use flat files, either really on disk or in an S3 bucket, right? So essentially you're just storing the data as it comes in. Usually you take like one line per data point. And that actually works remarkably well. So there's lots of support functions in Pandas to read like CSV files, JSON files, HTML, and so on. So there's like it's very easy. So you read one line, you convert it, and then you can construct a data frame from that. One of the big advantages of this is it's very easy to set up, and it also scales fairly well. I mean, you can always, especially when you go into the cloud and has F3 buckets, right? You don't have the problem that as you gather more and more data, let's say at some point you have a few 100 gigabytes or like a terabyte of data after a year of data collection, actually inserting more data usually doesn't become slower, which can be a problem in some of the other approaches I discussed. And usually the way you also do it is you organize the files depending on the frequency and the rate of the data by day or by hour, and that also gives you quite good random access capabilities, right? So if you want to say, I want to analyze the data from last week, so if you store it by day, you can get that very quickly. And so only if you go like into the files and it's very large, then you might have to skip and search a lot before you actually get to the point. But if you have a good estimate of how much data you will get per day, then you can set up in a way which works fairly well. And that all brings us to the main disadvantage, and that's of course that it's not very efficient if, let's say, you have 10 million data points per day, but the metric you're actually looking at only is like one of many configurations, and then you would have to filter through the whole data set to get that out. That doesn't work very well. And it also doesn't work very well if the data is not already reasonably in order, right? So usually you always, if you collect data from sensors, you always have some clock skew. So the order of the data might not be perfect, which is usually not a problem. But if the data is like very unordered or so, then it's also a problem, because then either you have to do a lot of work storing the data, right, that you make sure it ends up in the right buckets, but then it's not that easy anymore. Or if you get the data, then you have to read much more data than you actually need to filter down on the time range you're interested in. Right, but still so the first version of this is always just flat files, and because that also works with many tools. It's not that complicated. So the other thing, the next sort of classic thing is, of course, to store the data in a SQL database, which is very nice because you can then do this complex queries on the data to get time ranges out. You can put secondary indices on all the things you're interested in, and that is very fast. And you can also have, like in the query, you can aggregate, right? So let's say you store something per minute, but you're actually interested in the data per hour, and you want to compute the mean over this time. right? Then you can sort of already do it in SQL in the query with the group by clause, and that allows you to do the pre-processing already when you get the data in a very efficient way. So the main problem, I think, my experience with SQL databases is, so they're built for this transactional case, right? So they're usually ACID compliant, which means that on each update, a lot of work goes into making sure that data is, like, inserts are atomic, and you can have transactions and rollback, and data doesn't sort of, so you have a lot of guarantees that the data is actually consistent, which you often don't need if you have time series data. And the main problem is also because as the tables grow and grow and grow, inserts become less and less fast, right? So usually you have some decline, and by the point you have a few million data points in your table, inserts might be too slow for you to handle. So one way to go around this is sort of to have periodically set up new tables, so that, because you're always mostly only inserting to the end of the data, sort of, so you can do that in a way that you so once the data, like a day is done, you move that to another table, and then the writes don't slow down. But then, of course, like doing the query becomes more complicated because you have to do the query across different tables. So there are some projects like Timescale DB, which has a nice website, which tries to do exactly this, and then have this extra abstraction on top of the collection of tables, so that you don't actually have to do this over this additional work to do on query time. But still, so I would say for many cases, I think having a SQL database might be nice, because you have this easy access. And Pandas also has ways of getting the data. But if you really have very high frequent writes, then this might not be the right choice. There are other databases, and I want to talk about two of them. So one of them is Cassandra, which are actually used a lot as backend stores for time series analysis applications, especially in monitoring, right? So there's the project like Grafana, where you can put in all the metrics from your data center, and then you can have nice dashboards for all this stuff. And behind this is a database, Cassandra, and I wanted to talk a bit about it because it's quite interesting how the data model of Cassandra somehow actually is a good fit for time series data. So Cassandra is one of the premier NoSQL databases, right? It has a completely peer-to-peer setup. It makes it very easy to scale, so you can just add a new node. It doesn't have any master or something, and then the node they redistribute the data on the cluster, so you can very nicely scale it out. And the main part about putting data in Cassandra is that you have to think about, like, how you want to query the data, and then make sure you put it in there in a way that is very easy to query, right? Because the query language itself is not that powerful. But there's an interesting thing in the data model of Cassandra, and that's the following. So the basic abstraction in Cassandra is like a table in SQL, so you can have different fields. But for the table, like for each entry for the table, what you do is you define two kinds of keys. So one is the partition key, and that defines where the data is stored, right? So because it's a distributed database, for each piece of data, they have to make a decision where to store it and the replicas, and usually you want that the data is stored very evenly on the cluster. And that is what the partition key controls, right? So when you define the schema for the table, you sort of say, okay, this and this is the partition key here. And then there is a clustering key, which you can use, and that allows you later on to sort of do range queries on the data, and they can be used in a way that you can easily access time ranges in the data. So, okay, so how does it look like? So let's say we have a table, and what we want to put in is the metric ID, so that is the ID of some sensor data that we're going to measure, and then a day and a timestamp, and we have the actual value of the metric, okay? And the way you would set this up in Cassandra is that you say the partition key is a combination of the metric ID and the day, right? So to make sure that the data is nicely distributed on your cluster. And then you have the clustering key on the timestamp, and that allows you to do range queries here. So you can sort of say, give me for this metric on this day, and then give me everything from morning till evening, from 6 to, I don't know, 6 a.m. to 8 p.m. And then Cassandra is able to fetch that data very efficiently, although it might actually be on different clusters. And you can even combine this clustering key, and then you can have like a hierarchy of things where you can do range queries, right? And that way, you have a database which is very fast for writing, so you can put a lot of data in there, but still gives you the ability to select these time ranges very efficiently. And it also allows you to, over these range queries, then do simple aggregations like averages, maximum and minimum. And these are actually used as a backing story. So Kairos DB is a time series database which is used on Cassandra and, as I mentioned, Grafana. And these are used in production, and they collect like huge amounts of metric data and then allow you to extract data very quickly. Okay, and then the final approach I wanted to talk about is just to use a search engine like Elasticsearch for time series, storing time series data. So Elasticsearch is actually like a document-centric search engine. So you can have like the entries are documents which have many, many fields. And what out of the box, what Elasticsearch does is that it sort of builds indices for all of the fields, and it's very efficient at doing these kind of lookups, right? So you can essentially put in data which is very detailed, and then Elasticsearch is very good at picking up the documents which match your query. And the interesting thing is that Elasticsearch also comes with its own aggregation framework, so you can, in the query, define aggregations, which also help you a lot with doing this time scaling thing. And finally, Elasticsearch also can scale out quite nicely. So as you get more and more data, you can actually make it larger and larger and larger. So you can scale out the cluster to deal with all the data. And Elasticsearch also, the stack comes with a nice tool called Kibana, which you can actually also use to create dashboards and so on. So there has been, so if you search around on the internet, you see a lot of people who are using Elasticsearch for this kind of approach. I think the sort of the downside here is that because it's actually more like a document storage search engine, so the kind of setup you have to make sure that this runs very efficient is not that straightforward. And you also have to do a similar thing as with the databases, that you make sure that the data sort of ends up in different buckets for different days, so that the search, that the writes are still efficient. Yes, and also Elasticsearch in itself is not really optimized for huge write volumes, right? So the idea is more that you have many updates, and then it's really optimized on the search side. Yes, but so it could also be, especially with this Kibana stack, could also be very interesting version setup where you can store your data and then already do some analysis in the query side. Okay, so these are the very brief overview. I also don't want to go a lot into the details how to do that, because it could be very complicated. But I think that the general idea is, so flat files works very well when you don't have that many metrics. A database is very nice for starters, but doesn't really scale that well if you get lots of data. And then if you get to the point where you have lots and lots of data, then you should definitely look into something like Cassandra, which has been used for these use cases. So there's one final thing, which is actually not really a database per se, but of course you can also use current big data technology like Spark to do the first extraction step, right? So because so Spark is very much optimized also to working with this flat file model, so you can have your data on S3 or an HDFS buckets, and then to extract data and do some first steps. Spark is also a very good approach to reduce, sort of to get from the big data set to the point where you have the actual data that you want to do and use the time series modeling. Okay, so this was the overview for that, and next we will come to more advanced methods for time series analysis.